So till where did we see the previous class? Yeah. I didn't. So what was the last concept you saw, guys? Relation between electric. So E is equal to minus dV by dr, right? So after that we solved a problem also. Right? You can share the screen here. Okay. So the next concept is message stop. Okay. So the next concept that we are supposed to see is when you place a dipole in external electric field. We discussed this concept in the previous show. So you already have a dipole, and the dipole is placed in the external electric field. What will happen to it? On the door, basket. So when you place a dipole like this, I'm assuming by now you would have got the idea what will happen in this case. What will happen? It will start experiencing torque, right? So QE will act in this direction and another QE will act in the opposite direction. Due to which there will be a torque of P vector cross E vector in terms of vector quantity. Whereas when you write it in the terms of scalar quantity, it is going to be P sin theta. Okay. Now, when you have this kind of a dipole, let's say you disturb from its equilibrium. What you're going to do is you're going to slightly disturb from its equilibrium by turning it slightly in the clockwise direction and release it. What will happen? So, when there is a torque that is already there and there is a displacement that is getting created. So, this torque multiplied with the angular displacement is going to give us a quantity called as work done. So, what will happen in this scenario is when this kind of a scenario occurs, there will be some work which is being done on this material, and that work will get stored in some form of energy. What energy is it going to get stored as? It will get stored as the electrostatic potential energy. So, one thing not to get confused with is the electrostatic potential energy which we saw in the beginning. That is different compared to the electrostatic potential energy of a dipole placed in the external electric field. So, here the topic is going to be potential energy of a dipole. Write down the heading. Potential energy of a dipole in external electric field. So, potential energy of a dipole in external electric field. So, when the torque is there and there is a small displacement d theta that has taken place, then there will be a small amount of work dW that will be done, which is given as tau d theta. So, what is the value of tau? It is PE sin theta multiplied with d theta, which is going to be dW. But what do we need? We need the total work done. So, total work done W will be equal to integral of PE sin theta into d theta, where the value is going to change from theta 1 to theta 2. So, what I am saying is, if the object is revolved from one angle theta 1 to another angle theta 2, then the total work done is given as integral of theta 1 to theta 2 PE sin theta. So, P and E are constant. So, PE is taken out, integral of sin theta d theta from theta 1 to theta 2. So, what is the integral of sin theta? It is minus cos theta. So, PE into negative of cos theta from theta 1 to theta 2. Is the point clear? So, this will be equal to right. So, when you substitute the upper limit and lower limit, it is going to be minus PE into cos theta 2 minus cos theta 1. So, this is going to be the amount of work that is being done, and it will get stored in the form of electrostatic potential energy U. Okay, and this is a formula that is to be remembered. So minus PE into cos theta 2 minus cos theta 1. This is going to be the value of the electrostatic potential energy of whom? Of a dipole placed in external electric field. Okay. So if I take the absolute value, right, can I write U is equal to minus PE cos theta? If I take theta 1 to be 90, for instance, then can I take it as minus PE cos theta? Right. So this can also be written as negative of P vector dot E vector. So when you have P vector cross E vector, it is going to give you the torque. When you have P vector dot E vector, it is going to give you the electrostatic potential energy. Clear with this? Right. Now, based on this, there is a concept that we are going to see, which are called as special cases. So, in the special cases, right, the first point that we need to understand is when the value of theta is equal to 0 degrees, you will get U is equal to minus PE because cos 0 is 1. So theta is equal to 0 degrees. You substitute, you will get 1. Second, theta is equal to 90 degrees. It will be U is equal to 0 because cos 90 is 0. When you substitute theta is equal to 180 degrees, you will get U is equal to P into E. Okay, you will get U is equal to P into okay. Now, listen to this carefully. See, this is how the dipole is. Observe my hand. This is the direction of electric field that you have to imagine. So this is a positive charge, there is a negative charge. So in which direction is this system going to revolve with respect to you? Revolve in the clockwise direction. So the torque is generated into the plane, it is going to revolve in the clockwise direction. Now having said this, now if you see, if the value of, see, suppose I place a dipole like this, right? I place a dipole like this, where this is the positive charge, this is the negative charge. What is the direction of dipole moment? It is in this direction. And what is the direction of electric field? Same. So in that scenario, what would be the energy associated with it according to the equation I gave? Minus P. Meaning of it is, if the dipole is placed in such a way that the dipole moment and electric field are in the same direction, if you disturb the system, right, means what I'm doing is, let's say it is like this. If I disturb the system, if the system takes a turn in the direction in which it is disturbed and comes back to its original position, then this is said to be in stable equilibrium. What is happening? If I disturb it like this, it is coming back in the same way. You are able to feel it? Right, it is coming back in the same direction. You call this as a stable equilibrium. Whereas, forget about theta is equal to 90. Theta is equal to 90 means the dipole is like this, the electric field is like this. The next scenario is the dipole is in this way, where this is the positive charge, this is the negative charge, and this is the direction of electric field. P vector is in this direction, E vector is in this direction. So, in this scenario, if I disturb it, it will not go back like this, rather, it will take a 180-degree turn and come and stop like this. What is happening? When the positive charge is in the direction opposite to the electric field, that is when the dipole moment is in the opposite direction of the electric field. When you disturb the system will not go back in the same path along which it was disturbed. Rather, it will take a 180-degree turn and then come to this position. So this kind of a scenario is said to be stable equilibrium. Sorry, unstable equilibrium. It's said to be unstable equilibrium. So to put it simple, in stable equilibrium, so this is the condition for stable equilibrium, and this is the condition for unstable equilibrium. It's very simple. Any object will take a bigger turn and then come to rest only when it has, listen to this first, then you can write it. I told you, in unstable equilibrium, it will take a turn like this and come and stand, right? Any object will be able to take that much amount of turn only when it has more amount of energy. So for example, if I ask you to walk from here let's say 5 kilometers, you will be able to walk only when you have energy, or else you'll try to sit in that position. You'll be lazy to move when you don't have energy, right? That's what is happening in the first case. Why? You look at the value of energy, right? One is minus PE, one is plus PE, and one is 0. So among minus PE and plus PE, which is least value? Minus PE. So in the stable equilibrium condition, what will happen is it has a less amount of energy. That is why it is trying to come back along the path in which it was disturbed. It is not trying to restrict or do anything. Whereas in unstable, it is trying to take a 180-degree turn. So this is a very, very important concept, and this is often asked. Most of the time they'll ask you, what should be the angle between the dipole moment and electric field for unstable equilibrium? If you memorize, okay, 180 is the answer. But if you understand, even if you forget, you will be able to read it. Okay, so unstable equilibrium, what is the logic? Energy will be more. Stable, it will be less. Is the point clear?
Yes, sir.
So shall we move on to the next one? Is there a problem based on this concept? Check the concept after this. That one at the bottom. What is the question? Okay. So what is that? How do you solve that? So what is the page number? 65. So page number 65. Right. Look at the problem. The example. So read that question and tell me how to solve. Example 2.5. There are two charges of what magnitude? 7 into 7 microcoulomb and so one is 7 microcoulomb and the other is 2 microcoulomb. Okay. Then there's some the coordinates are given. No, 7 microcoulomb is placed where? minus 9 comma, this one is pasted 9 comma 0 comma 0. Okay, then what are they asking? Find the so u is equal to what? K q1 q2 divided by r, because there is not a dipole. This is the reason I'm doing this problem now. You will write the formula of P e cos theta only when a dipole is placed in external electric field, whereas there is not a dipole in the first place. Why is it not a dipole? The charges are not same and the distance of separation between them is also not small. Right? So you need to use the formula of K q1 q2 divided by R. What is the value of K? Substitute the values and solve it now. 9 into 10 power 9 into 7 into 2, okay, minus 2, 10 power minus 12 divided by 18. So this will be 9 into 10 power 9 into 7 into 10 power minus 6 into 2 into 10 power minus 6, the whole divided by 18. 9 into 2, 18, and this will be 10 power minus 2. So 7 into 10 power 9 into 10 power minus 12 into 10 power 2. 7 into 10 power minus 1, or it is going to be 0.7 joule. Am I right? So is that the answer? So minus 0.7 joule. Because minus 2 is still. They ask magnitude. What is the question? I told magnitude will be taken into consideration. Whenever you are dealing with scalar, you need to take the charge, sign of the charge into consideration. It is minus 0.7. What is the next part of the question? So here I will take the minus sign, because there the work done was that you got the minus sign because of the work done by the external force. Here it is the work done by the field itself. So there if you take minus, here if you take this. That's what minus 0.7. Magnitude wise 0.7. That's it. Okay. 7 into minus 13. Really? That's the answer given at the back. That's what is there. No? 7 into 10 power 9 into 10 power minus 12 into 10 power 2. 7 into 10 power minus 1 only, 0.7. So what is the next part of the question? Work done by whom? Work done. Yes. So what will be the work done? It will be exactly the opposite of this. If there is the amount of energy that is needed to bring the system together, work done to break the system will be exactly opposite of it. It will be 0.7. What else is there? Next part. So if you take the system and place it in the, okay, what is going to be the energy? So did they give the values? Suppose the same system of charges is now placed in an external electric field. This is not a uniform electric field. Why is it not uniform? How did I look at the expression and say it's not uniform? Because they are given E is equal to A into 1 by R square, right? A is some number 9 into 10 power minus 5. Sorry, 10 power 5 coulomb per meter square. Basically, that is energy density. What energy density? So not energy density, charge density. What charge density? So it is surface charge density. Okay. So since electric field is a function of displacement, E is inversely proportional to R square, it is not uniform, rather it is non-uniform. Okay. So what would be the electrostatic energy of the configuration? So how to solve this? So what will happen? Will there be a change? See, think, let's not worry about the answer. Let's try to understand the science behind it. Initially, there was no external electric field. Now you brought in some external electric field. Due to that external electric field, what do you think are the changes that is going to be experienced by the system? System in the sense, the plus 7 and 2 microcoulomb, individually, what is going to be the impact on them? One thing, E is equal to A divided by R square, right? So we know that E is equal to minus dV divided by dr. Am I clear with this? So A divided by R square is equal to minus dV by dr. So take the dr to the other side. dV will be equal to minus A divided by R square into dr. So what will be the value of B when you integrate on both the sides? Integral of minus 1 by R square is 1 by R. So it becomes A divided by R. So to put it simple, the position of plus Q is the position of positive charges minus 9. Minus 9, 0, 0. For this one, it is, see, basically they are supposed to be on the same line on either side of the origin, right? What will be the energy that this is going to have within itself? So energy possessed by the first charge, if I call this as the first charge, will be equal to the charge itself multiplied with the potential at that point. V as a function of R. It is not V into R. V as a function of R. What will be the value of U2? The charge multiplied with the potential as a function of R. And there is already potential energy because of these two charges. So this is an additional potential energy, this is an additional potential energy. So how much are they going to be according to this formula? So U1 will be equal to, what is the value of Q1? 7 into 10 power minus 6 multiplied with, what is going to be the potential? It is A divided by R. A is how much? 9 into 10 power 5 divided by, what is the value of R? Centimeter. So 9 and 9 are gone. So what is that you're left out with? 7 into 10 power minus 6 into 10 power 7. So it is going to be 70. What about the potential energy of the second? Minus 2 multiplied with A by R. So 9 into 10 power, minus 2 into 10 power minus 6 into 9 into 10 power 5 divided by 9 into 10 power minus 2. right? How much will you get? 9 and 9 will get cancelled. You will get minus 20 here. You will get minus 20 because here I got 70, here I'll get 20. So what is going to be the total energy? 70 plus minus 20 plus minus 0.7. So 70 minus 20 is 50 minus 0.7. It is going to be 49.3 here. 49.3. Clear with this? So the part that is not given in the textbook is the integration issue. You do not understand why you actually got the A by R. So done copying?
Yes, sir.
Next one. Did we do 2.4? Yes. We did not. That's square problem. Try 2.6. See, one point I would like to tell you before you proceed to that problem, right? Electric field is defined as the negative of potential gradient, right? What is the unit of potential? It is volt per, what is the unit of distance? Meter. So the other unit for electric field other than Newton per coulomb is volt per meter. That is what is given in the problem. Volt meter inverse. Okay. So next time onwards, ensure that you know this. Similarly, What is the formula for flux? E into A, right? So what is going to be the unit of it? Newton meter square per coulomb, right? So instead of Newton per coulomb, I can replace it with volt per meter into meter square. Meter and meter will get cancelled. Volt meter is another unit for electric flux. But you see, sometimes what they will do is they will not give you the physical quantity. Based on the unit, you need to make a decision of what physical quantity it is. Am I clear with what I'm saying? Right? So make a note of these two units. Apart from that, solve that problem as well. So the power will be off. Those are online.
Yes, sir.
See, guys, I have to close this class because we don't have power here and inverters are going to shut down. Is that clear?
Yes,
Okay,
sir.
sir.
So we'll continue the rest of the next class. So one more thing, see next week I'm traveling, but I'll be taking the class online for next week. So see, since I have the first batch at 4 o'clock, right? Most of them are from the nearby school, so that is why they directly come here before. But what happens is since it's online, I need to give them some time to reach home, so I'm shifting to 4:30. So each class will be shifted by half. Since instead of 6 to 7 for next week, we'll have it from 8:30. So similarly, the previous class was for the answer will be from 5:30 to 6:30. So make a note of this. Find out the results. It's very time.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.